All right, this is lesson 12.4, exploring square roots and rational numbers. Okay, so a square root, listen. You ever seen this symbol before? Like the 81, that symbol right here, this guy, right? The square root symbol. Looks a whole lot like the division symbol, right? So what's the difference? There's a little tail here. You see the little tail right there? That's the difference. Square root symbol. Now, the square root of a number. Have we dealt with this a little bit this year? Yeah. A little bit, right? What does it mean? The square root of a number means, what does it mean, Jonathan? What number times itself is 81? What number times itself is 81? What is that? 9. So the square root of 81 is 9. I won't get into this, but it's technically 9 or negative 9. Now, why is that true? Because what is negative 9 times negative 9? What's a negative times a negative? 81, right? So do you see that it's either or? Do you see what I'm talking about? For you guys now, no. The answer we're going to go with is 9. Okay? The square root of 81 is 9. Got it? Okay, give me another one. Tell me this. What is the square root of 4? 2. What's the square root of 36? 6. What's the square root of 100?
10.
What's the square root of 144? Are you all following this, right? Because 12 times 12 is 144. 10 times 10 is 100. 6 times 6 is, right? Okay. All pretty simple. All pretty simple. Now, here's the deal. Here's the deal. A rational number is a number that can be written as a fraction. A rational number is a number that can be written as a fraction. Okay. You've never dealt with irrational numbers before. I'm going to explain that to you here right now. Rational numbers, rational. If somebody's rational, that means that they're thinking properly, right? They're thinking smartly. They've got their heads screwed on right? Rational means that it's good. It can be written as a fraction. Like if I gave you the number 6, is that a rational number? Can 6 be written as a fraction? Yeah. How would you write 6 as a fraction? 6 over 1. Do you agree that 6 is rational because it can be written as a fraction? Do we all get that? What about the number 17? Is 17 rational? Yes. Why? Because it can be written as a fraction. How would I write it as a fraction? 17 over 1, right? Okay, that's kind of simple, right? It seems stupid, but that's true. Okay, what about this? Do you know this right here? What is 0.3 with a line over it? Do you know what that is? Can that be written as a fraction?
No.
Yes, because 0.3 with a line over it means that it's 0.3333333, which is 1/3. 1/3 is 0.3333333, right? Goes on forever, which is this. So I'm going to give you the rule. The rule is if there's ever a repeating decimal, I'm telling you now, if there's a repeating decimal, it means that it is a fraction, that it can be written as a fraction. So if you ever see a repeating decimal, it means that it is rational because it can be written as a fraction. Here's what I'm talking about. I'll give you a little advanced lesson here. 0.8 with a line over it. If there was no line, how would you write that as a fraction? 8/10, right? 8 over 10, right? Since there's a line over it, it's not 8/10, it's 8/9. If I gave you 0.41, how would you write 0.41 as a fraction? 41 over 100. Are you all following me here? I need more nods or I need to go back a lot. Are you all following that 0.41 written as a fraction would be 41 over 100? Yes. We got that for real? Like you get that? Yes. Okay. If I put a line over the 41, it's not 41 over 100. What do you think it is? 41 over 99. If you ever see a repeating decimal, I'm telling you that it can be written as a fraction. Okay? One more quick little thing here. What about this? If I have 0.836 6. Can that be written as a fraction? Yeah. It would be what? Yeah, 836 over 1,000. Okay, so every decimal is a rational number, right? A decimal is a rational number because you can write it over a fraction. You can write it as a fraction. What happens if I go like this? If I make it a repeating decimal? So if it was 0.836, 836, 836, 836 forever, that's how you'd write it, 0.836 with a line over it. How would I write, what is that? Oh, I'll be so impressed if somebody can tell me. What is that written as a fraction? Kendall?
836 over 999.
Correct. Instead of 836 over 1,000, if it's a repeating decimal, then it's just 836 over 999. You have a question, John?
Like, why wouldn't it just be written as like, if it was like 8 repeating, so what if it was like 8 repeating over like 10 repeating?
Listen, that doesn't make any sense.
Okay.
So 0.888, since, when does the 8s end? At what point do you get to stop writing the 8s and put it over something? When does that ever end so that you can go, okay, now that it's ended, I can put it over something? When would that ever happen? It would never happen. So that's why you have to put that line over it. And I'm just telling you that it's that 0.8 with a line over it can be written as a fraction. What is 0.8 with a line over it? As a fraction? Instead of 8/10, it's 8/9. Question?
So is 0.9 repeating? Would it be 9 over 9?
No. Oh, that's a good question. 0.9 repeating. I don't know. That's really good. How would you write that as a fraction? I don't know. That's a good question. Because it can't be 9 over 9. Right? That's 1. Huh. I don't know. It's a good question, though. Anyway, I'm showing you this so that you'll know what a rational number is, okay? Is 3/5 a rational number? Is 3/5 a rational number?
Yes. No.
Well, can 3/5 be written as a fraction?
Yes.
Since it is a fraction, is it rational?
Yes.
Okay. Right? What makes a number rational? If it can be written as a fraction. So if you see a fraction, what if it's negative 3/5? Can negative 3/5 be written as a fraction? It is written as a fraction, right? So what about negative 1.4 with a line over the 4? Is that rational? Yes, it's still repeating. It's negative 1.1 and 4/9, right? But it's still rational, right? It can be written as a fraction. So negatives don't change anything. Okay, let's talk about an irrational number. You might be asking, so what's irrational then? You agree? Like all of a sudden, like I'm kind of giving all the numbers you know about. Here's an irrational number. Tell me this. What's the square root of 1? What number times itself is 1?
1.
Square root of 1 is 1. Okay. What's the square root of 4? 2. Okay. What's the square root of 2? What number times itself is 2? Well, 1.5 times 1.5 ends up being 2.25. So that's not it. What other number? What else do you want to try? 1.25. Let's try 1.25. So we're trying to figure out the square root of 2. 1.25 times 1.25. First of all, the very fact that this 5 times 5 makes a 5 down here, that means that the end is going to be and there's going to be decimals and, oh, right, that's not, right? You see where that's not going to equal 2. Right? 1.4 times 1.4, when you multiply the two 4s, that makes a 6, and oh, that's not 2. Right? Here's the deal. There is no number that multiplied by itself is 2. No matter what you choose, it ends up being like 1.41457. I mean, like it ends up being a bunch, and guess what? It never ends. No matter where you stop, if you took whatever you stopped at and multiplied that by itself, does it actually equal 2? No, it will come real close. It'll end up being like 1.99999999999, but it will not equal 2. There is no number times itself that equals 2. Therefore, since that number never will end, guess what? It's not rational. Okay? It's not rational. Any square-rooted number that is not a whole number is irrational. Square root of 2 is irrational. Square root of 3, what number times itself would be 3? Square root of 4? 2. That one's a rational number because it's a whole number.
No, wait, isn't rational just be able to do over a fraction?
Right, so how would you do it? Square root of 2. Whatever number we choose. 1.14, 1.41, and so when do you get this? It never stops, right? It never ends, so you can never put it over a fraction because it can't be done. It never ends. Yes? On a calculator. It will go as far as it'll go. If you, on a calculator, if you typed in the square root of 2, it would end up being 1.414 and then like 5670 and then it would stop. But the calculator doesn't go any further than that. It only has like 8 digits. That's it.
Like sometimes when you do something that can't happen, it's like letters.
Right. It'll put an E, like error. Yeah. Yeah. So no, any number that you choose for this, even if it's 1.414, whatever, blah, 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 that's not the actual answer because that's just an estimate. This is just an estimate because is 1.414 times 1.414 exactly 2? No. So it's irrational. Any square root of a number that is not a perfect square is irrational. Let's name the ones that there is a square root for. There's a square root of 1, square root of 4, square root of 6. What's the square root of 6? What number times itself is 6? 9. Square root of 16. Square root of 10. What number times itself makes 10?
Not bad.
What number times itself makes 10? None. 25. Square root of 36. Square root of 49. Square root of... What's next? Notice this. Stop. 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 What's the pattern? Do you recognize the pattern? What's the square root of 1? Square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is... Square root of 25 is... Square root of 36 is... Square root of 49 is... Square root of 64, right? Then what? Square root of 81. Then the square root of 100. Then the square root of 121. Then the square root of 144. Then the square root of 169. Then the square root of 192. Right? And each one of those is simply, what is the answers here? Do you see it? You see it? Those are the only square roots that are less than 192 that are rational. Every other square root is not an exact answer. Okay? It's not an exact answer. Question? So just wait. Let me finish, and then I'll. They don't even ask you to do those like that. They only ask. Now here's the deal. They do ask you to use a calculator. You all should, before you leave the room here, you should borrow a calculator or whatever so you can do these. If they say this, square root of 10, we all know that answer is, what's it called? Irrational. It's an irrational answer. So we're going to have, in order to write an answer to this, we're going to have to, in order to get this answer, we're going to have to do something. When we write our answer, what's it going to end up being? It's going to be an estimate, right? It's going to be an estimate. No matter what we write, it's going to be an estimate. They say to round to the nearest tenth. So when you get 10, square root of 10, somebody type in the square root of 10. What's it come out to, Slade? It ends up being 3.16 what? 22. 776. Is that the exact answer? No, that's going to be close. If I took that, hey, do me a favor, multiply yours. Now just type in times 3.1622776 right here. Write that in. Type that in. Oh, it ends up being 9.9999 because 3.16227776 times itself does not equal 10. It's close. 9.999999996. Right? It's close, but it's not exact. So, they said to round to the nearest tenth. Do you remember how to round to the nearest tenth? Look at the tenths place. He looks to the right, sees a 6. He goes, oh my goodness, he's more than 5, so I go up. 3.2. The answer to the square root of 10 would be 3.2 if they're asking you to round to the nearest tenth. Are you paying attention? Get it? Okay. Are all square roots irrational? Square root of 1. Is that rational or irrational? It's rational because the answer is 1. Can 1 be written as a fraction? Yes. Right? Okay. I think you guys will do okay here. You're going to need to borrow a calculator to answer the square roots. They ask you for the square roots of a couple of things. You'll just need to borrow a calculator for 2 seconds, and then you'll be fine. Let me give you your homework. Page 589 to 590, 5 through 29 even, and 41 to 47 even.